Hello everyone, so this is Unit 1, Lesson 5, Linear System Word Problems. This is the last lesson in Unit 1, yeah, everybody's favorite. You knew it was coming, word problems. So we are going to keep these problems relatively simple. We're only going to go over a few different types of problems, but they're all going to involve creating and solving linear systems in some way, shape, or form. So I didn't write down the actual learning goals here, but your learning goals here essentially are going to be to solve word problems that use linear systems, as well as to write your work in a easy way to understand that is systematic, logical, and helps you to solve the problem. So I'm going to show you what I mean. I essentially have a scheme of doing that in this lesson. Okay, and this is the scheme. So whenever you have one of these problems, you're going to have to state your variables. So if you remember going back to the first lesson in Unit 1, you have to say what L is, what W is. So don't just like start using L and W for length and width of a rectangle. Say let L be the length of the rectangle in meters or something like that. You're then going to create equations for your linear system based on the information from the problem. Solve your linear system, check your solution, and then write a statement to answer the problem. So one of the learning goals, as we said, is to follow this scheme so that your work is laid out logically. It's easy for me to follow, it answers the question, and it also lays it out so it's easier for you to think your way through it, because it's not a straightforward question this time, right? Word problems, you have to interpret what's going on. Okay, first question. Jaskaran has 1065 made up of dimes and quarters, so he has that much money, and the money is all in dimes and quarters. He has 54 coins in total, so how many dimes and how many quarters does he have? Okay, so we know this is going to be a linear system that's going to involve two equations, and you're going to have two variables, which typically up to this point have been x and y, but we don't have to use x and y. I'm going to use d and q. Because we're dealing with dimes and quarters, and that's going to make it easier for me to remember which one's which when I'm doing the problem. So we're going to say let d be the number of dimes and let q be the number of quarters. In these types of problems, typically the amount of money is not going to be unknown. It's going to be the number, right? Because that's actually what you're looking for here. Okay, so in money problems like this, you're typically going to have these two types of equations. One type of equation is going to be for the number of actual coins that you have, and the other equation is going to be for the value, how much they're worth. Okay, so we know that we have 54 coins in total, so the number of dimes plus the number of quarters should be equal to 54, right? If I know however many dimes I have and however many quarters I have, when I add them together, I should get 54. In terms of the value, the 1065, well, that means that the value of the dimes and the quarters should add up to 1065. And the value of the dimes will just be 0.1 times d, right? Because if I have 5 dimes, then that's $0.5, right? 50 cents. So because my 1065 is in dollars, I'm going to put this in dollars. So each dime is worth $0.1, right? 10 cents, $0.1. And so the number of dimes times that will give you their value. And for quarters, they're each worth $0.25 or 25 cents. So if you do 0.2 times the number of quarters, that'll give you how many dollars you have, right? 4 quarters is $1. 4 times 0.25 is 1. Okay, so those are my two equations. And once you've gone this far, essentially what you have is a question that's just like all the other questions that we've done in the last couple of lessons. You have a linear system, and you can solve it through substitution. You can solve it through elimination. You could also solve it through graphing if you want to. So because I have just a d and a q here, this is pretty easy to do substitution with. So I'm going to use substitution. Okay, I'm going to isolate for d. So I bring q over to the other side. D equals 54 minus q. Right? That's a very easy equation to isolate a variable for, which is why I'm doing it this way. And then once I have 54 minus q, that's my d value. So I'm going to substitute 54 minus q into d for equation 2. So I've just done this very, very quickly. But what you'll notice here is I have equation 2, 0.1d plus 0.25q equals 1065. And then I'm just going to take d and throw it in there. So instead of d, I'm going to use this. So as I said, I've done this relatively quickly. Distribute that. And then you can see that the negative 0.1Q and the 0.25Q go together to get 0.15Q. 5.4 goes over to the other side. I divide both sides by 0.15 to isolate Q, and I get 35 for Q. So I have 35 quarters. Okay, that's pretty easy. If I have 35 quarters, I can sub that in to D plus Q to find out what D is, and D is going to be 19 dimes. So you can check your work like I've done here with a left side, right side check. And as we've said before, if you want to do more of an informal check, then you can just show me that if you put 19 and 35 into your second equation, that it works. So in other words, or you don't even have to do that, sorry, what you could do is just take the 35 and put it in for D into your second equation and solve for Q. And when you solve for Q, you should get the same number, 19. You can also just do a left side, right side check. To be honest, doing it this way is not really that much slower in this kind of problem where you're dealing with all these decimals. But as long as you can justify that you have the correct answer, then that's fine. This is a word problem, so you can't just leave it here. You do have to answer the question directly. You have to provide the person asking the question with an answer. So we include a therefore statement. Therefore, Jasperan has 19 dimes and 35 quarters. Problem solved. Moving on, you're typically going to see this type of problem as well. So the difference between two numbers is 45. 3 times the larger number less 5 times the smaller number equals 75. Find the numbers. So I have two numbers. I'm going to say let x be the bigger one, let y be the smaller one. Okay, so I know that if I'm doing one number minus another number and I get 45, I'm going to be, the larger number will come first, right? So x minus y equals 45. So x is the larger number and y is the smaller number. X minus y equals 45. That's, remember, difference means subtract. And then 3 times the larger number, so 3 times x, the larger number, minus 5 times the smaller number is equal to 75. So again, once you get to this point, pretty straightforward. It becomes just like a question that you've seen before. So again, I'm going to use substitution here because this really works out easily. I just got to bring the y to the other side, and I already have what x is. I can just substitute it. So x minus y equals 45. So I'll bring the y over. X equals 45 plus y. Right? Simple. I have x. So that can now go in for x into your second equation. Okay, so x is replaced with 45 plus y. I distribute. I rearrange everything and solve algebraically, and I get y equals to 30. So there we go again. Once I have my y value, I just sub it into the other equation, and I can get my x value. So 30 is going to go into here. So x minus 30 is equal to 45. X is 75. So I have my two numbers, 30 and 75. Okay, so I can do a left side, right side check. Again, I'm not going to go through this too much. I just write both equations separately, and I show that if I plug in my 75 and my 30 for x and y, I get the same answers on my left side and my right side for both equations, and I do. Okay, again, therefore statement. So therefore, the larger number, should have a comma there, therefore the larger number is 75 and the smaller number is 30. Period. All right, last type of question is another money question. So Jasmine has $8,000 to invest and would like to earn $500 from the money. Okay, so this is how much money she is going to be investing in some kind of financial something. And she's going to get $500 or wants to get $500 for her investment. So she has a stock that's been getting a 10% annual return. So essentially, every year she gets 10%, and she also has a savings bond that pays 4% annual interest. So again, every year 4%. So what we want to do then is see, okay, how much will she have to put in each to get $500 at the end of the year? So we're going to say let x be the amount that she invests in the stock, and let y be the amount that she invests in the savings bond. Okay, this is kind of similar if you think about it. Really, this is kind of just a more advanced version of the coins problem, because we have here. X plus y, right? The amount in each is equal to the total amount of money. And then this is the equation that gives you the value. So we get 10% of whatever she puts. She gets 10% of the money in her stock, right? So however much money she puts in there, at the end of the year, she's going to get 10% of that. And for the savings bond, that's going to be 4%. So just like you put 0.1 and 0.25 for nickels and dimes, 0.1 or 10% of the money she puts into her stock, and 4% or 0.04 of the money she puts into her savings bond, when you add those together, she wants to have that equal to $500. Okay, so again, substitution is really easy here. I've picked a lot of questions where substitution is easy because you just move one of these variables over again. So that's what I've done. So x gets moved over. I have y. So I then look at my second equation and I replace y with 8,000 minus x because that's what y is. Again, remember to distribute, and you solve algebraically in the same way that you always do. So these numbers are a little bit scary. I guess the only real difference here is knowing how to translate percentages into decimals, right? So remember, you just take the percent and divide by 100. So 10 divided by 100 gives you 0.1. 4 divided by 100 gives you 0.04. Okay, check. Looks much the same. So I'm not really going to go over that. You can look at that. And then we need a therefore statement. So therefore, she should invest $3,000 in the stock with a 10% annual return, and she should invest $5,000 in the savings bond that pays 4% annual interest. So then if you add those two up together, you have $8,000 that she's investing. And again, you can check it works for this equation as well. Okay, so main kind of takeaway here, I guess, because we haven't done really that much new here at all, is please follow the steps, state your answers as clearly and as carefully as possible, and define everything that you do. So don't just start writing down X's and Y's and D's and Q's. Make sure you very carefully define it. It might be a bit annoying, but it's going to make your life easier in the long run. It's going to make you less likely to mix up your variables, which is, believe it or not, pretty easy to do. So please take the time. It will be worth your while. That's the end of it. Thank you.